Hello, my name is Professor B, and I'll be giving you a lesson in calculus today. And the lesson that you're going to be receiving is dealing with related rates. This is a famous problem. It is the sliding ladder problem. The top of the ladder will be sliding down, and the bottom of the ladder will be sliding out. So the rate of the top of the ladder sliding down is related to the rate at which the bottom of the ladder slides out. Okay, so this problem is how fast is the base of the ladder moving when the ladder is at a height of 5 feet and is sliding down at a rate of 24 feet per second. Okay, so here's the top of the ladder. Here's the bottom of the ladder, and this ladder is 13 feet long. Okay, so basically it says it's sliding down at a rate of 24 feet per second. So this direction represents X, this direction represents Y, and since it's going down, the rate that it's sliding down at is actually going to be negative 24 feet per second because it's going in the down direction. Okay. If you were to look at this ladder, you can see that it resembles a right triangle. So we can use the Pythagorean theorem in order to come up with an equation to solve this problem. So let me draw the triangle. It's a right triangle. Okay. So the hypotenuse is 13. We want to know how fast this bottom is moving when the height, which represents this side of the ladder, is 5 feet. So we have 5 feet right here. Now, how many feet are down here? Well, what can we possibly use in order to figure that out? Anyone? The Pythagorean theorem. If you said that, then you got it right. Great. Give yourself a hand. Okay, so this bottom part I'm going to call X. And this part over here I'm going to call Y. Excuse me. So the Pythagorean theorem is usually a squared plus b squared equals c squared. But in our case, is going to be x squared plus y squared equals, and I'll just say L squared, which stands for the length of the ladder. Okay, so now what we're going to do is we're going to take the derivative of this equation, and let me just fill this in real fast. X squared plus y squared equals 13 squared. Okay, now let's take the derivative. So we're using implicit differentiation. So this derivative is going to be 2x dx dt. We're using dt because everything is with respect to time. So when you do implicit differentiation, you do the derivative as you always would, and then you put d, whatever letter you're dealing with. If this was a z, it would be dz dt. If it was a q, it would be dq dt. But if it was a t, then since there's a t on the bottom with a dt, you would just treat it regularly. But it's not. So that's just a little bit of talk about implicit differentiation. But okay, so here we go. Let's continue here. Plus, and then we're going to go 2y dy dt equals, and even though I know this is 169, if you take the derivative of a constant, it's always 0. So equals 0. Okay, now let's solve for, what are we going to solve for here? Well, what we are looking for is this bottom part right here, and this is the x direction. So we're looking for dx dt. All right, so we're going to minus 2y dy dt from both sides, minus 2y dy dt. And now let me do my little thing here. Boom, shot, and drop. 2x dx dt equals negative 2y dy dt. Okay, one last part. How are we going to get the dx over dt all by itself? Well, we're going to divide both sides by 2x, chop, and then we're going to drop up here. So here we are, dx dt equals negative 2y dy dt all over 2x. This can be simplified even further. These two 2's can cancel out. And we have dx dt is equal to negative y all times, I'll put parentheses, dy dt all over x. Now what you're going to do is, since the height is 5 feet, you're going to put that in for your y, but for your x, you're going to have to use the Pythagorean theorem. And I'm not sure if a lot of you have this memorized, but you should try to memorize this. And there's some famous right triangles. The most famous one is 3, 4, 5. Everybody pretty much knows that, but there's another one that's 5, 12, 13. So just know that if you see any multiple of 5, 12, 13, then it'll work. So this x is equal to 12. I could prove that for you by saying 5 squared plus 12 squared equals 13 squared. 13 squared is 169. 12 squared is 144. 5 squared is 25. 144 plus 20 excuse me, is 164. If you add 5 to 164, what do you get? What do you get? 169. Yes. All right. So 169 equals 169. Good. So x is equal to 12. All right. So here we are. dx dt is going to be equal to negative of what the y is, which is 5, all times negative 24 feet per second. This is 5 feet right here, everyone, just for the sake of units. All over, the x value is 12 feet. I would put a little ft in here. Let's see if I can do that. Okay, so 5 feet. Sorry about any sloppiness, but so here we go. 12 can cancel. It goes into itself once. It goes in 24 2 times, so now you have a negative 2 left. The feet cancel with the feet, and you have negative 5 times negative 2 is positive 10. And that is feet per second. dx dt is equal to positive 10 feet per second when the ladder is at a height of 5 feet. Okay, thank you for watching my calculus video. And if you live in San Diego, I can tutor you one-on-one. I live in San Diego. If you do not live in San Diego, I can tutor you over Skype. And this is my Skype ID. It is Math Professor .B. Okay, that's Skype, and then my number is 619-309-7083. You can feel free to send me a text and let me know how you like the video, or if you need help in calculus or any other math for that matter. I can help you out with that. Geometry, algebra, stats, any of those math. But thank you for watching my video, and I can't wait to hear from you. Take care.